Welcome to the subject software engineering. Today, we'll take up the topic architectural design. Point number one. As the architectural design begins, the software to be developed must be put into context. So, students, when you start architectural design, we must see okay the context of our new software that we are going to build. That means, in this case, we should see what are its surroundings. Point number two. That is, the design should define the external entities, other systems, devices, people that the software interacts with and the nature of the interaction. So you should study in total about what are the other systems it is surrounded with. Point number three. This information can generally be acquired from the analysis model and all other information gathered during requirement engineering. Students, this information we can get it from analysis model that has been developed or information available during requirement engineering process. Point number four. Once the context is modeled and all external software interfaces have been described, the designer specifies the structure of the system by defining and refining software components that implement the architecture. Students, once the context is ready and once we define all the interfaces, then what needs to be defined is the components and the structure. Okay, and then we have to implement the architecture. Point number five. This process continues iteratively until complete architectural structure has been derived. Now let us go for next subtopic, that is representing system in context. Students who have studied, when you go in for architectural design, we must define the system's context. Point number one. A system engineer must model the context. Point number two. A system context diagram shows the flow of information into and out of the system, comma, the user interface and relevant support processing. Students, this context diagram should show how the information flows into the system or out of the system. It should also indicate the user interfaces and the supporting processing. Point number three. At the architectural design level, a software architect uses architectural context diagram to model the manner in which software interacts with entities external to its boundaries. Students, there is architectural context diagram which will describe the context in which the new system is being developed. Okay, and how the software is going to interact with the entities which are external. Now students, this is architectural context diagram. Okay, so here you can see in this diagram, okay, there is a target system at the center. That means target system is the system that you are developing. Then on the very top you have got superordinate system. So these superordinate systems are systems which are at higher level, which will use the services of the target system. Then at the bottom you have got subordinate system. So this subordinate system, okay, uh, gives support to the target system. So that means your target system depends upon the subordinate system. On the extreme left, you have got the actors. So actors are the entities which will use, okay, the services of the targeted system. And at the right, you have got peers. So peers are, okay, which communicate with the target system. More about this we'll study in the next slide. And small rectangles which surround are the interfaces which communicate with the target system and its surroundings. Now we'll explain the architectural context diagram. Now referring to the figure, system that interoperate with the target system are represented as one subordinate system, then superordinate system, okay, users and peers. First we'll consider superordinate system. So these are systems that use the target system as part of some higher level processing scheme. So these superordinate system are at higher level and they take the services of the targeted system. Second, subordinate system. So those systems that are used by target system and provide data or processing that are necessary to complete target system functionality. Students, as the name suggests, subordinate system. That means these systems are going to support the targeted system and it will these subordinate systems are going to render services to the target system. Next, point number 3, peer level systems. So these are systems that interact on peer to peer basis. That is, peer to peer basis means information is either produced or consumed by the peers and the targeted system. That means there is good communication or communication at higher level between target system and the peer system. Point number 4, actors. So these entities, that is people or devices that interact with the target system by producing or consuming information that is necessary for requisite processing. Students, actors are the entities, could be people or could be devices which will interact with the targeted system or which will use the targeted system. It may consume the information or produce the information. Each of these external entities communicates with the target system through an interface. These interfaces are represented in the shaded rectangles as far as architectural context diagram is concerned. Now we'll go for one example, that is architectural context as far as safe foam security system is concerned. Okay, so you can see here, that is security okay, targeted system is at the center whose job is to provide security functions. Then superordinate systems are safe home product and internet based system. Subordinate systems at the bottom are the sensors, okay, and the peers are the surveillance function, okay, which you can find at the right, and towards left the actors are nothing but the control panel or home owner. So this is actual, okay, example of the architectural context diagram that we are considering. So now this particular example is safe home security system. Now we'll go to the defining archetypes. So an archetype is a class or pattern that represents a core abstraction that is critical to the design of an architecture for the target system. Students, this is a new term called as archetypes. So these archetypes is nothing but abstraction at very high level. So archetype is a class or a pattern that represents core abstraction that is critical in the design of the architecture of the target system. Okay, so it has critical functionality and very important aspect as far as architectural design is concerned. Point number 2, in general, a relatively small set of archetypes is required to design even relatively complex system. Students, so archetypes are okay a model which will serve certain function. So such archetypes are required in smaller in number even if you want to develop a complex system. Point number 3, the target system architecture is composed of these archetypes. Archetypes form the basis for the architecture but are abstractions that must be further refined as architectural design proceeds. Students, these archetypes we know these are abstraction at higher level, and necessary to develop any architectural design, but these abstractions which we call as archetypes should be further refined so that you can produce a good architectural design. Now these are archetypes you can see in this diagram. Okay, there are four archetypes. At the very top you got a controller, then there is a node. At the bottom left you got detector, at the bottom right you got indicator. So this is a UML diagram you have studied, unified modeling language. So in unified modeling language you use such diagrams, and there is communication between the controller. You can find a rhombus type of connector and a diamond and triangular type of connector. So these are representation as far as UML diagram is concerned, which are studied in earlier chapter. Now archetypes for a safe home system. We'll take one example. Considering the safe home security system, we are following archetypes. One is node, and second is detector. Third is indicator, and fourth is next, node. Node represents a cohesive collection of input and output elements of the home security function. For example, node may comprises of various sensors and second, a variety of alarms or output indicators. Point number 2, detector. Detector is an abstraction that encompasses all sensing equipments that feeds information into target system. Students, detectors are information providers to the home security systems. Indicator. Indicator is an abstraction that represents all mechanism. For example, alarm siren, flashing lights, bell, for indicating that alarm condition is occurring. So indicator is nothing but which will help and give you signal or give the signal to the security system. Point number, it could be alarm siren, flashing lights or bell which can be easily recognized. Fourth, controller. So it is an abstraction that depicts the mechanism that allows arming or disarming of a node. So controller is a unit which will allow other units to function or defunction. Either it will allow them to work or it will stop from working. So main job is to control other units. Now I'll go to next subtopic, that is refining the architecture into components. Students, as you have studied, once the archetypes are developed, or once architecture context diagram is developed, we should design the components which forms the subparts as far as system is concerned. So point number 1, after the top level abstraction, that is archetypes, have been defined, the design begins to move closer to the implementation domain. Students, as you know, archetypes are very important aspects. A small set of archetypes will help you to develop a complex system. So once these archetypes, which are nothing but top level abstractions, have been defined, then we are very close to the implementation of the system. Point number two, components are identified and represented within the context of an architecture that supports them. Students, once the architecture context diagram has been defined, components have been identified, then okay, you have to identify the components that are represented within the context of an architecture. And point number three, finally, specification instantiation of our architectures are developed to prove the design in the real world context. Students, the final step is that you should develop the particular systems, okay, subfunctions or instantaneous as it is properly called, and prove that the system can be developed and can be implemented in the real world context. Students, today we have taken design architecture, which is very important topic. Okay, so please write this as notes and study them. If you got anything, you can give me a call. Thank you.